Hello everyone. This video is on the Knewton Alta assignment, section 3.6, called Graph Absolute Value Functions. Alright, so this video is just me going to be going through a preview version of this assignment. So please understand that the questions I see in this video may not be the same questions that you see when you work on the assignment yourself. But the objectives are the same. So the questions should be similar enough that watching me go through a few of them here helps you out in some way when you work on the assignment yourself. Alright, so the assignment page here, we got the title, got your mastery bar, objectives. It looks like there's only the one objective here. Nice. Then below the current objective, you have a question related to that objective. And at the bottom of every question, you should see a feedback button, or you can send feedback to Knewton if you need to. You will not have the instructor cheat button. That's for instructors only. You will have a more instruction button. If you're struggling with a particular topic, click on this and you'll be taken to some reading or some videos or both related to that topic, and you'll be given some questions related to that instruction, and hopefully having the instruction up will help you get through the assignment problems. Alright, so this first, all the questions are on just graph an absolute value function. So we're saying, given the graph of f of x equals the absolute value of x, right? Remember, this is one of the absolute value function, this absolute value of x, was one of those toolkit functions, right? That library of basic functions you should know the shape of. And it's like this V-shaped graph here, right? They got the graph of y equals, absolute value of x going on, f of x equals absolute value of x right here. And we're asked to move these points around to display the graph of this function. Now, I don't like that they called this f again, because if they told me this was f, and now they're telling you this is f, they should have called this something else. Just y equals, or maybe even a new name like g of x or h of x. So I'm telling you right now that there's a little error here. Maybe you want to send some feedback. Maybe I will after this video is over. That they should, if they called the original function f, they shouldn't be calling the transformed function f as well. Alright, so let me write this out. Alright, we'll do this by hand first. So we're starting with, f of x equals the absolute value of x. And I'll graph that here by hand. And I'll do this in like an orangish color. So you got 0, 0, right? The absolute value of 1 is 1. And the absolute value of 1 is 1. And the absolute value of negative 1 is 1 as well. And just like in the picture they gave us, it's this graph here, like a V-shape graph. Alright, so there's the graph of f, right? F of x equals the absolute value of x. Now we're asked to graph, I'm going to call it just y equals. Alright, you can call it some other function. They shouldn't have called it f again. Now this is 2 times the absolute value of x minus 3, and then minus 1. Now, if you remember our little discussion in section 3.5 on transformations, this expression here is the same as the following. 2 times, and then instead of the absolute value of x, we have the absolute value of x minus 3. So that'd be f of x minus 3, right? It's the function f, but x is replaced by x minus 3, and then you got the minus 1 after. So remember how function transformations worked. For First I'll do the times 2, then the minus 1. So the transformations that would occur to change this graph that we're given into the graph they want would be the following. One is I would multiply all the y coordinates by 2. I'll say multiply y's by 2. Right, cause a vertical stretch by a factor of 2. So 0, 0 would stay at 0, 0. 1, 1 would go to 1, 2. I'm just going to put little tiny dots because they're going to be a lot of movement here. Negative 1, 1 would go to negative 1, 2. And we get a thinner V shape. Right, you get a vertical stretch by a factor of 2. But then this minus 1 here would move everything down 1 unit. You'd shift down 1 or subtract 1 from the y's. Right, subtract 1 from the y coordinates. So now this 1, 2 goes back down to 1, 1. Negative 1, 2 goes down to negative 1, 1. And 0, 0 goes down to 0, negative 1. Right, so now I got these 3 points. Again, I'm not going to draw it yet until I'm done moving everything. And then finally, the inside stuff, right? X is replaced by x minus 3. Right? Remember, when x is replaced by x minus h, that causes some horizontal shift. Now, h here is positive 3, right? X minus h, x minus 3. That moves it right 3. Right? You shift it right 3, or just add 3 to all the x coordinates. Right? So instead of 1, 1, move it right 3, that'll be at 4, 1. And, 0, negative 1, right 3 will be at 3, negative 1. And this negative 1, 1 move right 3 will be at 2, 2, 1. Right? And then my final graph is this, as these points. Oops, that's a terrible. My hand shook. And there you go. There's y equal. There's our graph, right? The one they want. Our function. So you got 3, negative 1, 4, 2, 4, 1, 2, 1. Now you could do the transformation thing, or you can find what's called the vertex. Just find where the absolute value will be 0. So that's going to be at x minus, where is x minus 3 equal to 0? That happens at x equals 3, and then when you plug 3 in, you get negative 1, and this is called the vertex. All right, that's the lowest point or highest point of this V shape. 3, negative 1, and then just plug in other points. Just make a table of values, and if you plug in 4, you'd get 1. You plug in 2, you'd get 1 as well. You could use symmetry. But you find the vertex first, and then plot other points. And once you got a point on either side of the vertex, you can draw that V shape, and there's your graph of your absolute value function. Okay, so you can use transformations, or just what makes the expression inside the absolute value 0. Then plug that in, get the output. You got your vertex. And then find a point on either side of the vertex and draw the V shape in, draw the absolute value graph, and you can do it that way too. Alright, so back to the assignment. Let me move these points. Right, so like I said, we got multiply that by 2, multiply that 1, 1. I moved to 1, 2. Right, then I moved everything down 1 unit. Right, and then I moved everything right 3 units. Right, when I was doing the transformations, and there's your 3, negative 1, right, the vertex. 4, 1, there's 2, 1, right, points on either side, and it's the same graph that I drew by hand. Now after you submit, you should be told whether you're right or wrong. You may be given another chance at things, but after your last chance, you'll be told if you're right or wrong and be given some sort of answer explanation. Please read through the answer explanations. Just make sure you understand why you got something right or wrong, so you can learn from things for the future. Fix your mistakes. All right, so this next one, I'm just going to talk these out. Oh, actually, no, you know what? I'll do this one. Now, again, they're calling them both f. They shouldn't be calling them both f. Right? They're totally different functions. So one should be f, the other should be g or something else. Just, again, I'll send some feedback to Knewton, or maybe one of you could as well when you're doing the assignment. You know, the more feedback we send about that, the faster it'll probably be changed. But yeah, they both, again, they both shouldn't be called f. They are totally different functions. But we're asked to graph, you know, y equals 3 times the absolute value of x plus 1 and then plus 3. So yeah, I'll write this one out. I'll just write this one out, and then the last couple problems I'll just say out loud. So we're asked to graph y equals, you know, 3 times the absolute value of x plus 1 and then plus 3. You know, again, like I was saying, I'll do that thing with the vertex, that vertex method. It's pretty quick. Now you could do transformations, you know, take the original absolute value of x, you know, do a vertical stretch by a factor of 3, then move it up 3, and then x is replaced by x plus 1, so then you would move everything left 1 unit, right? You can do all that. But if I think, you know, where is this equal to 0, right? So take the expression inside the absolute value symbol, set it equal to 0. That's at x equals -1. Right, so the vertex is going to be x equals -1. Now, when x equals -1, you know, this is 0, and then you got plus 3. Y would be 3. All right, so it's going to have the point -1, 3 on it. There's that. And then just find a point on either side. You know, here's some other points. So let's make a table. Say 0. If I plug in 0 for x, you know, you'd have 3 times 1 is 3 plus 3 is 6. You have 0, 6 is on this. And then you could use some symmetry and say -2, 6 is also going to be on it, right? Because that's 1 unit to the right and 6 up. 1 unit to the left of the vertex, 6 up. Or you could just plug in -2 and you would see that you'd get an output of 6 as well. And once you have the vertex and a point on either side, you should be able to make that V-shaped graph, right, for these absolute value functions. Yeah, so I'm just going to move my vertex, you know, -1, 3, and then the other point to 0, 6, and it should be the graph that I want. So -1, 3 for the vertex, and then this other point I'll just move to 0, 6. And there's the graph that I'm looking for, the graph of this function that they want me to draw. Great. And again, they describe it using transformations and whatnot. But, you know, if you don't want to go through all the transformations, you know, the way I'm showing you is fine too. But only for these absolute value of a linear function things, right? These V-shaped graphs. All right, so moving on, we just got a couple more of these. These I'll just talk out. It's the same stuff. So I hope you see that the vertex of this new function would be at -3, -2, right? If I plug in -3, this would be 0. And if you plug in that, it'll be 0, and then you got -2. So -3, -2 for the vertex. And then if I were to plug in, say, 0, I'd get 4. You know, 0, 4 would be on the graph, right? Because you have 2 times 3 is 6, minus 2 is 4. And then you got 0, 4, you got -6, 4, right, on the other side, symmetrically at x equals -3, symmetrical about x equals -3. And that should be enough for the graph, right? There's a graph of the absolute value function they want. Great. All right, so find the vertex, find some other point. Should be no problem. Or use transformations, right? Multiply all the y coordinates by 2, then subtract 2 from all the y coordinates, and then subtract 3 from all the x coordinates, right? Move it left 3 after all that. Whatever you want. Gives you the same graph anyway. All right, then one more of these. So again, the vertex, when it eventually comes up. So the absolute value has an expression x plus 1 in it, right? So -1 will be the x coordinate of the vertex. And then I plug in -1, this will be 0, and then I have -2 for the output. So -1, -2 for the vertex. And then if I were to say plug in some other value like 0 again, if I plug in 0, you know, 0 plus 1 is 1, the absolute value of 1 is 1, -3 times 1 is -3, minus 2 is -5. So you have 0, -5. And there you go. And then they got some other points plotted here, but that would be the absolute value function that we want. And notice how it flipped over. And the reason it flipped over is because of this negative number out in front here. You know, if you took a function and multiplied it by -1, remember that flips it over the x-axis. It causes a reflection, a vertical reflection, and you see that happening in my picture here. Great. All right, so however you want to do it, transformations, you know, cool. Find the vertex, then just find some other points, also cool, right? Both ways give you the same graph at the end. And again, they shouldn't be calling both of these f. Right, just keep that in mind. And that should be it for this preview version of this assignment. Like I said at the top of the video though, you know, the questions I saw here might not be the same questions that you see. But the questions, you know, the objectives are the same. It's the same objective, graphing these absolute value of a linear functions. So hopefully watching me go through these ones pretty quickly here in some way helps you when you're working on them on your own. And thank you very much for watching.